Everyone, hello. My name is Devon Stewart. I work at Twilio. I work on a product called Programmable Fax. We send faxes. It's a lot of fun. So that is, I guess, the extent of where HTTP and faxes meet is at our API layer. And for the past 2 years, I've been actually writing this tool called Guardrail. Guardrail is a code generation for servers and clients in Scala, but also targeting other languages as well, primarily for the JVM, but also now via Scala.js, we also have support for Scala, for JavaScript-ish type stuff. So anyway, the primary problem that we ended up facing, the reason that we started writing Guardrail in the first place, was that as companies scale, as communication between teams becomes more important, as teams drift apart, have different technology stacks, and need more communication and strict contracts between the services, we had this problem where it was difficult to actually enforce that contract. If you write your documentation after you've written your code, then there's no guarantee that the documentation reflects the code or that the code stays in line with the documentation. There's no sort of guarantees at all. There are a lot of tools that are in place to try and reflect out documentation from code. In this talk, we will take pot shots at those techniques because they are not sustainable. I guess one of the other big thing that I found that was particularly important is having a specification language that is separate from your code, so that non-technical people can participate in that process. You can participate with the iteration of the interface and the definition of the technical components in a given API. There are a bunch of different tools in place to do this, primarily OpenAPI and RAML. OpenAPI and RAML actually sort of cover the same space. They tried to represent HTTP APIs in some sort of consumable way that other people can iterate on in a text-based form. Sorry, RAML is another thing similar to Swagger. Oh, I don't know. That doesn't matter. Unfortunately, RAML, for whatever reason, there were a bunch of tools to configure or to convert RAML and Swagger to and from each other. Swagger eventually became selected by the Linux Foundation into what it became today, which is OpenAPI. So the whole process of figuring out what the technology that the industry wanted to use ended up, unfortunately, RAML didn't make the cut. And just mentioning it here out of homage to them, the fact that they really tried. Good for them. The other thing is that even if I'm trying to use these documentation techniques to communicate different stuff between services, between servers, I want these protocols to be strongly typed. I want them to be at the very least well-defined, not even strongly typed in like rigorous type systems, but I want to be able to say with gRPC, I want to be able to say I want to specify a protocol, and I want to specify even with GraphQL. I want to be able to make these sorts of requests possible, make it possible to have self-documenting APIs. gRPC and GraphQL offer that. But the one big disadvantage as far as our company went, and the reason that Guardrail is the way that it is today, is because we wanted interoperation. We wanted to be able to talk with services that were not bought into this ecosystem yet. So while it's possible, if you're building a company from scratch, you may want to say, okay, yeah, no, Kafka and Avro for everything, and we can have this horizontally scalable pipeline for all the services to talk on. Awesome, I love it. But if you're in a big legacy company with a bunch of legacy microservices, how are you going to do that? And the answer is you know, baby steps. So here we are. The problems that are faced by existing offerings in this space, primarily with relation to Swagger, because that's where we are, OpenAPI, I should say. The problems with OpenAPI is that nobody wants to write YAML, and then additionally, nobody wants to write documentation, and nobody wants to keep the documentation up to date. unless you're in a very privileged space of having people that actually, like, this is their jobs. I envy you. I do not have that luxury. So the challenge for me was, how do I make the documentation part of the build pipeline? And how do I flip the script? How do I make it so that instead of trying to reflect out what a service looks like, statically analyzing that thing or runtime analyzing that thing, how do I make it so that the documentation is a first-class citizen in that respect? So this is the mindset that we came from. There are a lot of tools to try and either generate from a Swagger specification that quickly becomes out of date because you've generated the Swagger, you've generated Swagger into some sort of client libraries or server stack or something like that. Now you have all this legacy code that you have to maintain. You end up getting effectively a project. If you're familiar with Maven archetypes, this is something that Maven archetypes do. They just spit out this amazing stack of things that are obsolete immediately. Because now anytime that anybody updates the archetype, you don't regenerate your entire server stack. You're stuck. So we don't do this. We have a completely different strategy that involves building specifications, building servers and clients from OpenAPI specifications. We've got build tool integration for all of your favorite build tools. If your favorite build tools include SBT and Maven. Those are the ones we support, and so you're get on board with Maven. So the code in Guardrail is, I would say, one of the best tested code bases that I've ever worked on. We have 5 levels of tests in one code base, and this is to compensate for the fact that I hate writing tests and I won't do it unless it forces me to. So I built the system in a way that I'm forced to write tests, which is great because I'm more interested in writing types and making things like not compile if it's not right. But the tests are important because we're generating for Java, and so
Have you heard of that?
Yes, but I don't know that much about it, and I'd love to talk about it afterwards. Sorry. So the other thing is that Guardrail generates human readable code. So if you generate your code and you go into your service, instead of seeing line noise or everything is on one line with no white space or anything like that, it actually generates properly formatted structure. We use abstract syntax trees in the different languages that we support in order to make sure that the code that comes out is at least somewhat human readable. There's definitely going to be a lot of stuff that gets jammed in together because it's not aesthetically formatted. But we also, for Java, we run it through the Java code formatters, and for Scala Meta is under the hood, so Scala Meta has a pretty decent pretty printer built in. So we leverage those things. And then additionally, we don't use any sort of crazy magic. The goal of Guardrail was to generate something that sort of adheres to the principles of principled software development, right? So like no null, no exceptions, even if it's safe because it can't be wrong. I still don't want to be able to, I still don't want to have to add exclusions to wart remover for my generated code directory because now I can't trust the generated code remover because the code that is generated is living to a different standard than my own service. So we idiomatically work with the libraries that we support in order to make sure that there are no, crazy nonsense going on to the best of our abilities. Java requires some crazy nonsense, but it is what it is. At least in Scala, we support akka HTTP, which was our first offering, and HTTP4S, which has been a community contribution and has been maintained almost entirely by the community, which I'm tremendously grateful for. The underlying JSON infrastructure is through Circe, and we use cats to do all the functional stuff to wire everything together. So,
is it akka stroke play?
No. But I have heard that Play is making some tremendous inroads to support akka types. So I don't know whether or not that's going to materialize sometime in this decade, but it's possible. It would be awesome.
When you generate the logs for akka HTTP, you generate also the objects, right?
Yes. So all the DTOs for your protocol, as well as your clients and all of its protocol, and also your servers and those protocols.
Okay. And you support all the stuff, for example, optional fields, non-mandatory fields in the object?
Yeah, to the degree that we do support them. Now, there is a subset of Swagger that is supported, the subset of OpenAPI that is supported, and that subset is the stuff that we absolutely needed to get working. And so everything else now is just feature additions. So
you like rely on like regenerating the from scratch every time you build to kind of like an adverence schema with adverence maybe life cycle to make sure that if you change it,
yep,
it will regenerate.
exactly that. So if you change your specification and recompile, it will fail to compile. So, yeah. I'm sorry?
Make sure your developers don't turn the plugin off after they generate it, basically.
Well, they can't not, right? Because even when you ship it to your CI/CD, then it won't have those code. It won't have that code. You don't commit your code.
Oh, you're not committing.
Yeah, it's generating in the target directory. So it's it really generates every single time, and you yeah.
So it's not generating in the source directory.
Exactly. Yeah, this is, I didn't want to have to commit generated code because having like thousands lines of changes because I've changed like V1 to V2 and now the whole thing is different. Like it's useless. I'm more interested in a minified diff of these are the things that actually matter. And so target directory.
If you want, for example, to make authorization for some of the codes, and you want to create a materializer, a directive for authorization, make a SBT implementation for this. You support this?
So the way that this, can I answer that in 5 minutes? It's a good question, and I'll answer that when I have code on the screen for it, right? So let's talk about how to configure this for SBT and Maven, at least initially. We have 3 different runners. We have SBT build plugin, we have Maven build plugin, and we have a CLI runner. So if you want to run this in some sort of build environment that's different than what we have today, if you still like make scripts, I support it, we have that, so good. All the same features are available in all 3 of the different build tools. And then additionally, the CLI, I think, is somewhat different to normal CLIs that you're used to. So if we look at the SBT configuration, we've got the 2 lines that are required are adding the SBT plugin as well as a different client and server specification for each of your clients or servers. There's also Scala model. Scala model is just generating the DTOs. It doesn't actually require any of the other code. So the primary focus is put all of your configuration that are actually relevant for an individual client or server into these configurations such that if you have extensions to the guardrail type classes that are exposed, you can actually shim in via the imports configuration option. You can shim in your own types on top of what Guardrail already offers. So we'll see that in a minute, but all of the configuration for code generation is done in one place. So there's no sort of crazy runtime flags. This is the Maven generation requirement. This is the POM file. So if we scroll up to the top of the POM file, we can see that this is very similar to what we saw in the SBT configuration, where each execution is one of these. It's either a client or a server, and the configurations themselves require, like you pointed at a YAML file or a JSON file or whatever. We support OpenAPI version 2, also known as Swagger, and OpenAPI version 3. So again, to some degree, it's not all of the features are supported in all of them, and we're still working out some bugs between the 2 and 3 conversion, but for the most part, it is currently running in production, so we're happy with it. The main thing is that it ties into the generate sources lifecycle, so that's what makes this all possible. Yeah. So. Surprisingly not. We actually only have integration with DropWizard as of like 2 weeks or 2 months ago rather. So if you're using DropWizard, great. If you're not, pull requests are accepted. So let's look at what this looks like in Scala. So Scala is the one that's been around the longest. We've had Scala clients for now about 2 years, in production for about 2 years, like generating for a little bit longer than that. The servers have been in production for about a year and a half, came a bit after that, and HTTP4S came in around that same time. It's been open source for a year and a half as well, and the Yeah, the biggest thing is if we look at a Swagger specification, this is in Swagger OpenAPI 2. We also support OpenAPI 3, but this was taken directly from the tests, so I just copied and pasted, so that's why it's in 2. We support 3 as well. But we can see that this describes an endpoint living on localhost port 1234. On the login path, if you send a GET with the operation ID, actually this should be a post, sorry, I copy pasted this wrong. If I send the operation ID, or if I send rather the parameters, username in the form data to this path in a post, then it will call the login operation ID. The login is actually, the operation ID is the friendly name for developers, so that we can control the names of the methods that we're exposing to users. Now, the package on the JVM, so the X-Scala package, X-Java package, X-JVM package, is this hierarchy. I want to put all of this stuff into the users package. And because this is the final element in this package hierarchy, this ends up getting glommed into a thing called a users handler and a users route. So we can look at what that looks like now. So this is the generated code. This lives in the target directory, and I've omitted some of it here, but this is almost all of it. We can see that there's a trait here. If you're familiar with Scala, trait is an interface, or if you're not familiar with Scala, trait is an interface. If you are familiar with Scala, it still is an interface. It's just you're already familiar with it. Yeah, it's prior knowledge. So the main thing here is I want to call out the type of respond. I think respond is a really important thing to call out, because the type of respond here is actually a login response. It's not HTTP response. It's not akka response. It is login response. As a result, if we look at the actual object for login response here, notice that this is actually the singleton type, and then we respond with a future of the login response instance. The singleton type has friendly constructors for all of the HTTP methods that you have exposed in your protocol. So if we go back to the protocol, we can see that there's only one response. It's 200. There's no friendly names are supported in Swagger, unfortunately, in OpenAPI, so we have to do the mapping. But once you're in your code, once you're in the generated code, you're using friendly names for everything. So there is no body here either. This open close curly is a denotation in YAML for this is an empty object. So there's a bunch of other stuff that we could put here. We could put schemas. We could say this is the response that we must send back. This is the description for this thing. But because it's empty, we have no supported response body, which means that we must return with an empty 200.
And that's just because of how you wrote the user handler, right?
Yes.
Okay.
Yeah, all the stuff inside, we're marshalling this to the normal akka HTTP types. But by exposing this subset of HTTP is extraordinarily broad. It's way too much for any individual route to, if you look at the route, if you look at this, tell me, just spot check it to see if it's correct. I don't want to do that. So main thing is, by constraining HTTP into the stuff that actually matters, we can be more productive. We can make it so that everyone else can also be more productive. And then additionally, people who are reading it can be more productive reading it, reviewing it, whatnot. And then also, I want it to fail to compile if the spec changes. I want to not accidentally change my specification.
Wait, so this is the stuff that lives in the target directory as a result of Guardrail, or is this what you actually wrote?
This is what, no, this is generated.
Okay, whoa,
Yeah.
okay, word.
So let's look.
So you're saying just write it.
Yeah. So let's writing code. What a concept. So let's take a look at, like, I've got the users handler here, right? And so here's the users handler. I want to start with a blank users handler. If you're using IntelliJ, you say, I want a new handler instance. I want a thing of this. So if we try to compile this, we get an error because it turns out that we did not define the login function. This is an expected error. If I try to fill this out, this looks like this. We can actually run this. It will compile the handler. It will pass the handler to the user's resource routes function. That gives us back a akka HTTP Scala DSL server route. This is where your question comes in. This is a standard route. If you wrap this route in any other directives that are not supported by Guardrail, for instance, OpenAPI or any of those, not OpenAPI, OAuth rather, OAuth or any of the unsupported authentication schemes or whatever else you want to do, you can just map directives or transform the routes directly. This is primarily establishing a baseline. I'm not trying to prevent you from doing what you need to do. I'm trying to establish a baseline that we can start iterating on for moving forward. So.
And my question is somehow, if, for example, I define directive of authorization.
Yes.
And I want to enable to all routes, I need every time I declare a function to add this. No,
so we don't currently support having directives injected in each route, right? So we only support top-level directives. This may be a feature request that I welcome it, but the primary thing is if we open the door for arbitrary transformations or arbitrary directives, now the boilerplate increases and the lack of confidence creeps in. So if you want all of these routes to be authenticated, I would wrap everything in an OpenAPI or OAuth directive. And if you have non-auth directives, I would just generate a separate server and compose them together. So this has worked actually quite well for us, but we have limited constraint utility because this is microservices inside a company. So
if you wanted to throw something like certain privilege to do one set of routes and unprivileged other things,
yeah,
just keep them separate.
We actually have two different Swagger specifications in our primary repo. This is the external facing repo. We have the Swagger specification that our external consumers consume. And then we have an admin repo, which is on a different port, but it's still using Guardrail. So we still have all the documentation and all the same stuff. We have our admin routes as well documented as our public routes. It's like, who does that? So,
I have another question.
yeah.
If you generate more, you have more endpoints, you generate more routes that should be composed together, right?
Not necessarily. So we're adding a second parameter here, but if we look at this Swagger specification, we can actually imagine that there are more methods here. All of those methods would just be extra definitions on your interface. So if we go back to this interface here, each one of those would be separate methods. And in this routes, all of those routes would be composed together.
My question was something, okay, you have this generated code.
Yes.
You have, let's say, a bootstrap class that will start the service.
Sure.
And you said this generated code is not committed into
Correct.
Git. So when I write this bootstrap and I said this is the route and these are the function implemented for this, if I not commit the user handler, somehow my code will not compile. We will have some compilation because you will not find, for example, user handler.
Yeah. So to
First of all, should be generated and after this.
Yeah, to restate the question, so if the generated code is required in the implementation, how does it make sure that the code is there when it's trying to compile?
Yeah.
So this is done by the build tools. So the SBT Guardrail plugin actually is depended on by compile. So compile, anytime that you call compile, it will necessarily run the generate.
Okay, so we generate before.
It has to, and every single time that you hit compile. Exactly. So, and for any build tool, it should be the same way. Now, if you're using the CLI, you're completely on your own. You can commit whatever, or you can build that into your CI/CD pipeline. It's entirely flexible, entirely up to you how you want to use that. But at least for the SBT plugin and the Maven plugin, it is set up this way because otherwise it wouldn't work, as you're pointing out. So, yes.
So for the authentication scheme, right? So if you have the admin interface is separate YAML, how do you specify that all these routes are there?
So OpenAPI specifies authentication in its directives. So you can actually define an authorization field and all the authorization parameters. What I'm saying is that there's limited support for custom configurations for that. So right now we support HTTP basic auth. In my service, I'm also working on digest auth, and I'd like to add that into Guardrail proper. It's just I'm depending on a completely separate repository or a separate library for that implements just HTTP digest auth in isolation, no interaction with anything else. Works really well. But actually porting that over and making that opt-in so that people who don't have that dependency don't fail to compile, this is where sort of the end user ergonomics of how to consume a plugin come into play. And this is something that we're actively discussing on the issues. So I welcome, if you have opinions on that or if you want something like that, then definitely participate. I don't know Spring, so I can't answer that. But
Yeah, I mean, it has just like the concept of like an authoritative principle. It forces you to say like, when you actually put this all together, you better give me some implementation, usually via either like SDI or.
I believe that's how the Drop Wizard one works. So the what I'm saying is that Guardrail's Drop Wizard generator does that.
Yeah.
The Akka one currently does not do that. So the Akka one may need more, movement in that direction. But I think that Basic Auth, if I remember correctly, Basic Auth at the very least provides something, but internally we're on-auth relying on the service communication layer to do our auth for us. So this is effectively yes. So we're targeting our use case first, and then future stuff is feature requests. So yeah. But I'm definitely interested in this being exposed to the public internet because, I mean, why not? We should push the boundaries, right? So here we go. If we add an extra parameter, so to get back to our previous login with only the username as a parameter. I've been told by my security people that I would reduce trust in our company if I presented that we were using login with only usernames. So we also have to include passwords in some capacity. So this is that was the mandatory, like from my company, you have to say this thing, otherwise we're going to look like complete crazy people. Now that that's out of the way, let's look at how that ends up being consumed. If we change the protocol and we do nothing else to our code, what does that look like? We have our previous login function, the exact same thing that was on the previous slide. If I run this now, there you go, there's your compiler error, because it turns out that we needed the username and password variant, and the method login overrides nothing because we have this override def login. Method login overrides nothing, but the superclass does actually include this thing. So I guess in some build tooling, you might be able to automatically do some sort of migration. It already knows this is what you probably want, but it doesn't go all the way to migrate it for you. So this is at the very least something that I can look at and I can say, okay, cool. What I need to do is I need to add the next parameter. I need to add password, and then I'm still going to respond with a future successful response. Okay. So if we run this, we can see it compiles, everything's fine. So as things go, I believe that this is a pretty straightforward way of developing, and we've made a lot of progress internally for getting a lot of disparate use cases supported. So we support things like file upload on clients and servers. We support things a lot of the different kinds of ways that you pass parameters around, extensible headers, what is it called, open tracing, whatnot. So the normal stuff you want in production code. So yeah. There is a microsite available. It is at guardrail.dev. Highly recommend. It's currently a giant single thing. It's the book of Guardrail that I just sort of slammed out one day. And I was like, well, wait, we're releasing this as an open source product. It should have documentation. Yeah, let's write that. So the book exists. It's guardrail.dev. Looking to turn that into an actual microsite, but currently working on actual triaging issues instead of writing documentation. So if anyone else wants to get involved but they don't want to deal with the nitty-gritty of the internals of Guardrail, the documentation is welcome to be played around with. It is hosted on GitHub pages, so it should be fairly easy to open pull requests against the documentation to make things better. The primary repo lives at github.com/Twilio/Guardrail. Twilio is the company that I currently work for. They have been graciously supporting development of Guardrail. They actually were effectively the incubator for it for about a year. Twilio ran Guardrail internally for a lot of our services. We actually have Guardrail running in production in, I think, 4 or 5 different countries. So we have offices all over the world, and we have teams all over the world, and we have users all over the world. So that's kind of cool. We have a lot of people that are not at Twilio that are in the Czech Republic that also use Guardrail, which is surprising. So yeah.
Do you have any experience on managing like multiple versions of a microservice that, let's say you want to add a new parameter?
Definitely.
Obviously, when you get like large distributed systems, you can't upgrade them all at once. So
Yep.
any experience like handling that in terms of, you could do like major version of code, obviously, because you're code doing, you just say, but you have to leave the old one up and handle it with like a mesh or something?
So there's a product called Nelson that is supposed to do Semver-based routing for services. So when you bring if you bring 1.1.1 into load balancer, or you're now available, you're part of the mesh, and you have a new version 1.2.1 or 1.2.0. Consumers of that service will have to upgrade their build properties to support that version of the API before they'll be routed to that service. And Nelson manages, we can shut these services down. There are no more consumers. Exactly. Yeah, so I have not implemented it. I know of it because somebody talked about it at Bayhack, I think last year, it was excellent to see. I don't know anything else other than that. It looks like what I want, but I don't have that particular problem because my team is fairly self-contained and our external API doesn't change so frequently. What we have done is for our external API that does change when we add new features or if we do some backwards incompatible changes, what we'll do is we'll actually duplicate the entire route into something that is like a V2 / the same thing. And exactly, but
put V0 on there when you do the first one and then poke it.
I think that the difference is that because we have the explicit breakout of the methods between these services, you can actually do the routing yourself to not duplicate the code. You can upgrade an old route with new parameters or transform the parameters when you're passing the function call off to the other function that's going to do the work. So that's I guess the advice that I would give you is it's primarily that is just that it's made easier because you don't have to try and get this to be decomposed. So we do the decomposition for you so you can get to doing real work. So, yeah. And then I just wanted to call out, if you do want to contribute, so I mentioned documentation, the issues, we have actually a significant number of issues for the different feature requests that people are opening, and for HTTP4S, I mentioned that HTTP4S is maintained by the community, and we've had a number of people come in and just upgrade all the generated code from like 0.17, 0.18, now to 19, now to 20. So we've got a significant rolling release for support for HTTP4S because of the backwards incompatibilities between the API, but I'm tremendously humbled by the fact that people want to do this and use this product. So if this is something that you feel that the motivation of Guardrail is something that speaks to you, but we don't support your library, your framework, or your environment, I want to hear about it. I want Guardrail to help you do your job. I want it to be there for you. So we can talk about making changes even to Guardrail core that otherwise would necessitate significant work on the core maintainers team in order to support some use cases that we hadn't planned for. We're currently doing that to upgrade from Swagger 2 to OpenAPI 3, for instance. OpenAPI 3 supports just a whole new level of complexity that Swagger was unable to represent. OpenAPI 3 is a much better specification for HTTP services, and I recommend using it in the future. Currently, we're using the 2 to 3 converter internally, as well as some backwards compatible, forwards compatible shims to adapt the core of Guardrail to Swagger 3 or to OpenAPI 3's data model. We're currently trying to rip that stuff out and become fully OpenAPI 3 native. It's nights and weekends, how it is, open source. So when we get there. But during this process, we're learning a lot more about how other people want to consume this stuff, like what features they need in production. And so this is an opportunity, just open issues. Even if we don't get to it immediately, eventually, yeah, we'll or if you want coaching to implement features, I can talk. I actually have another talk later in this conference. It's an unconference talk tomorrow of using Scala Meta for 2.5 years. I have some insight into how to use it effectively. So trying to automate even simple code gen tasks, even things that you want to commit to your repos or something like that, just batch scripts or stuff that you want to automate, but it's not worth writing all the infrastructure and a full product around. Just like scriptlets, but just to build repetitive code. That talk is tomorrow, but if you're interested in the core of how any of these things work together, we're using a free monadic stack with all kinds of free monadic abuse on top of it in order to support all the different languages. We actually support different discrete abstract syntax trees for each language, and each of those abstract syntax trees is completely isolated from everything else. So we can add new languages that we didn't even plan for just by defining new ASTs for those languages and wiring them up to the core infrastructure, and then everything works. For the most part, you have to write the interpreters at the edge, but the core is completely language agnostic. It took about 3 to 4 months to rip all the Scala out of the core of the free monads, but now it's actually all type pointers to other types that haven't been defined yet. So the infrastructure around that's really cool. So ask me about that as well. So yeah, as far as this talk goes, this is the end. I appreciate it. Thank you for coming and listening. And I'll stick around for questions for a little bit longer. But yeah.
You mentioned the open tracing. Is that a fairly straightforward case of it, including the plugins for that?
So we don't.
Or
So we use the Lightstep plugins directly. So we use the Lightstep dependencies directly, rather, I should say. What I will also say is that Guardrail, I mentioned at the beginning that Guardrail is very much intended to generate code that you would write yourself. SPI was mentioned earlier. I have no interest in that. I'm sorry. I don't want runtime craziness. I don't want class path dependency nonsense. Some people might, I don't. As a result, this is something that you have to explicitly enable in your configuration. You say trace equals true, and then you provide some sort of... Someone is currently trying to adapt what is generated for HTTP4S to support the HTTP4S middleware. So once the middleware is unlocked, then we have the whole of entirety opened up to us. So yeah. I have never written HTTP4S services, so I only just looked at it and said, that looks awesome. Wish I could use that, and then went back to work. So this is my, at least what I'm currently trying to do is maintain the infrastructure and maintain the motivation to prevent it from degrading in quality. And everything else, as far as feature work, I'm here to support as far as moving things forward. So. Very much that. Any other questions?
I'm going to ask a Java question.
Do it.
On the earlier slides, you had like the client and server, and then you had like commented out Java server, Java client. And so from the single code base or single Swagger, you can run Guardrail and it'll generate the stuff in the Scala base and the Java.
Yeah. You can stick it in different packages. You can stick it in the same package. They probably won't conflict much. They might conflict. I don't know. The handlers will probably conflict, but the responses don't. Do you want to take a look? I can actually run it really quick just to look at the Java generated code.
That'd be great.
Yeah. Okay. Cool. And if anybody else has any questions while I'm doing this, I welcome them. So let's take a look at the extra one. Let's see. So one of the things that I mentioned is that the sources are generated into the target directory. So they ended up in SBT in source main, or source managed rather, and then these are the packages that I called out in that build.sbt. So if I say Guardrail, we'll run the generator. and we should see a JS04 directory show up. So here's the Java stuff. We have, pardon me, I do not write Java. I've never written Java. I don't know how this works. We can, wow, that's ugly. So,
Sorry, everyone.
yeah. Oh, no, that's on purpose. So if we look at, this is Jersey support, patch, shower, trace, definitions, users. So if we look at, this is what I wanted. I don't want all this other crap. Users stuff. So let's look at the users handler. So the users handler has this completion stage users handler login response, login, final username, final password. The response is a users handler login response. That is the login response abstract class. If you instantiate login response.ok, then it will actually do all the whatnot to lift it into a proper response for you and respond in the drop wizard specific way for making it all work. If there were parameters, this would have parameters. But there are no parameters, so it doesn't. So there's that.
Great, thank you.
Yeah. Yeah, excellent. I'm happy to help. If we look at the stuff that actually gets generated, we can see that in my demo or in the Swagger specifications in the talk, this should have been get. It actually should have been post the whole time. So the actual Swagger specs were post. The sample was get. But this is post, and then these are the parameters that we extract from the environment, and then we call the handler login with the stuff, and then when that gets completed, we actually do all the stuff to get it into the response that we need, and then like there's some sort of error stuff happens or something like that. And again, don't write Java. I know some of the words.
Can you see what I saw, was it Netty or Jetty in the
Jersey, I think.
Yeah, how would you integrate it with Spring? I mean, would it be...
I mentioned earlier that I don't know Spring, so I'm going to defer to the people in the audience.
This is Spring, but like it doesn't give you the Spring.
Yes.
It doesn't give you the authentication layer. That's
Right.
the main. I think it's the main like part. Like, that'd be the main like enterprise integration problem that I get rejected on.
That's fair.
Because like there's no strong security here whatsoever. No, right.
Yeah.
But if you have like a concept of just an authenticated principle instead of username and password, which is like a first class citizen with Spring and drop wizard.
Oh, totally. I'm not opposed to it. I'm just saying that this is the baby steps of where we're going, right? So we
like the idea of like generating it because that's I ran into this problem all the time where like people write this code and then you have to maintain it.
Yeah.
And they always screw it up.
Nobody wants that. Yeah, very much. Yeah, exactly. Good luck using it.
So just
Yeah.
so easy to change.
Yeah, definitely. Yeah. It reminds me of writing XSTs. It's just a walk in the park. Yeah.
Is there any way to like implement or like add in any of the other, or does OpenAPI, maybe it's a better question, like allow you to layer anything on top of this? I'm assuming that
OpenAPI supports custom authentication schemes.
Yeah.
And
that might be the answer, is that you just plug into like,
exactly. You want that static definition because you want the servers and clients to be able to run from the same service. You want to be able to say, I'm going to give this YAML documentation, I'm going to give this Swagger documentation to a security architect. And the security architect will say, yeah, it says this, perfect. Now we can run our brute force attacks or whatever to try and fuzz this thing, and then we can break it open. So.
I think I wonder, I'd be interested to see how it fits in the API, because that's kind of like Spring would do the same thing. It's like you can pass that things down, because you're going to end up needing that user.
It is just a string to object map in OpenAPI. So if you support a string that supports some sort of new authentication thing, another thing I should mention is that
Spring has like a context.
Yeah.
That
Context, right?
you grab it from that, but that's part of like the J2E stuff.
Yeah, I was thinking more like the web, whatever they're well, not necessarily MVC, but they'll be like a whole.
Yeah, the Spring application context,
Yeah.
XML file.
So I would like to call out that I mentioned earlier that we're using free monads for this. And we're using free monads for this not because they are fast or cool or neat or whatever, because this was designed to be extended by infrastructure teams at companies. So I Guardrail actually exists in two parts at Twilio. Guardrail exists as the open source component, and then we have our internal interpreters that adapt to our environment. That's where we override the open source open tracing with our own internal directives for Lightstep and whatnot. But you have complete control. This is one of the other things that I should mention, is that in each interpreter, you have complete control over the AST at every step because you are given the AST as parameters. So instead of string concatenation, reflecting out, trying to parse and whatnot, you can actually match on the actual abstract syntax tree that's generated by Guardrail anywhere else in the system. So this is imminently hackable. Highly recommend.
So the idea here is that like, you can take the abstract syntax tree that's expressed in the to interpret it into the string.
No, you wouldn't even do that. You would actually write, so we have, for instance, so if we look at, I wish that I could, whoops. So if we look here, we've got the HTTP4S generator, akka HTTP generator. So let's look at generators. And so you would implement your own, so if we look at, we've got Drop Wizard server generator, for instance. So the Drop Wizard server generator generates Drop Wizard servers. The Drop Wizard generator as a, when you say type is Drop Wizard or framework equals Drop Wizard, this actually calls the Drop Wizard framework interpreter, which, the Drop Wizard generator, which integrates all of the different components together. It knits the Jackson generator with the Ning async HTTP generator with the Drop Wizard server generator into something that is capable of supplying the free monadic interpreter for the entire stack. So you would write the component that you want to override as its own free monadic interpreter for your particular business logic. Or if you wanted to add Spring or something like that, you could write that and then contribute that to Guardrail proper. And then if you needed some specific things that you wanted to interpret in your own code base, you would override the methods that were specifically generating one component. Like this is the parameter. The parameter needs these additional override parameter whatevers. You do that. So that's what we do, and it works actually quite well. So, yeah. Any other questions? Yeah.
If you were writing a new web framework from scratch,
yeah.
would you use Stagger?
That's the only thing I would do at this point. I don't want to go back.
Because you were mentioning, you come to an enterprise and you want to migrate
Yeah.
something that's documentable. But from scratch.
What I would say is from scratch is important because if you start with your specification, if you start writing a server by hand, first of all, you don't know what it is going to look like until you get to the end. Also, you don't have any guarantee that what you ended up with is what you wanted. So if you start with a specification and then you write the implementation, you have two forms of truth that have to cross-check each other. So this is an important differentiation, I would say. And then additionally, making it easy to migrate as you add new features or deprecate old features, that's another thing that is tremendously valuable. Being able to say override def login, and then once login is deprecated in favor of this principal injection stuff, like what, don't need login anymore. Now login is no longer dead code because it won't compile because override doesn't override anything. So I would do it for everything. One other thing I should note, we've got 2 minutes, so I'll mention the future of Guardrail. Future of Guardrail, for me, is I don't want to have to stay on HTTP and JSON forever. This does not expose HTTP to you. It exposes something that looks like HTTP, feels like HTTP, pulls out all the parameters, but I don't know where username and password come from. They could be headers. They could come from the authentication object or basic, or even injected from some cookie somewhere, I don't know. They could come from anywhere, but those parameters are exposed to me as their raw values. If I wanted to do some crazy nonsense, I should not do crazy nonsense. I should look at trying to establish an interface that actually makes sense for a real HTTP service. Like you can write crazy cowboy code until the end of the day, but what I want is monomorphic, I hope I'm using that word correctly. I don't want these polymorphic response bodies. I want to be able to say, look, This is the entire schema that represents the entire response from this server at this point. It is mind-blowing to me how many, not to, let's just say, but any arbitrary company, have you seen this, right? You go to somebody's client library and they're looking only at the success case, and then everything else they just go, it's fine. And Akka HTTP, you can't do that. If you ignore the error response bodies, if your deserializer doesn't successfully consume the entire stream, you're leaking sockets. You have to wait until those TCP sockets time out. I don't want to have to explain that to junior developers. Not because I don't like talking to junior developers, more because this is stuff that they shouldn't have to care about until they are dropped into some repo that doesn't use Guardrail, and then they have to learn it. But up until that point, they could have built, good habits, I would say, and strived for better tools. So. Yeah, I think this is the last question. Yeah. No, I mean like after the whole. Yeah, because I don't want to make everybody else watch me listening to you tell me how servant works.
Well, I guess my claim is that like we use servants over Haskell.
Sure.
Okay. And we use servant and we just build our API type.
Yeah.
Building a microservice and we type it and make sure the server fits that.
Yes.
But we automatically get derived client.
Yes.
We automatically get derived Swagger.
Yes.
Specification. And even if we decide to integrate with an external API,
yes,
we just have to write that servant API type and we automatically get derived client.
Yes, definitely.
So I think, this is sort of the opposite approach where we're taking the specification and building the code.
Yes.
So it's more like we're building the type and the code is sort of generated.
I agree.
Type checked against it.
Yes.
I think that's really cool because now we can actually build more combinators in a servant type.
Sure.
To interpret it as like a RabbitMQ routing thing. As
sure.
well as a HTTP routing.
Yeah. So awesome. It sounds really cool. And I was actually sitting next to the person who wrote or currently maintains servant Swagger, I think. Yeah, he's here. Just talk to him. So we were comparing the different approaches, and they're both valid approaches. You can do whatever. You don't even have to write documentation, honestly. There's no one's like putting a gun to your head. So if you want this, and if you can maintain this, and if this is like this being the servant stuff, I think that is an excellent strategy. It is not something that worked for us or works for us because having the code be the single point of truth for this whole stuff means that you are locking off accessibility from the rest of your organization. You're exporting your Swagger specification, you're exporting your OpenAPI specification from your build, which is excellent for describing how your code currently works, but is useless for telling you, based on people you're working with, how you should change your API. Now you have to iteratively try and change the types in order to get it to line up. If you want to prototype new features, or if you're communicating what the interface will look like eventually, and then you are coding to that specification, stubbing out methods until they're done, you are now blocked for adding any new collaborators or consumers from your service, from any other people in the team, any other, for instance, if somebody is writing Java at your company, I don't know how your company works, my company, you've got JavaScript developers that need to know what the API looks like, and they're writing the API, or the Java developers, I want to write this integration. You build these reliances on this core of what the API will eventually look like, and you can write the types for that, and I would support that. But yes, we have a lot of cross-team collaboration from a single repo, and we're like bumping and everything. Yeah, pretty much. So I think we're done pretty much. I'm getting the signal in the back that we're over time. So anyway, thanks again, everybody.